So here atmosphere. Read the question. We'll try to 10 minutes time is there. We'll wind up this one. So first, slowly, there's a gas, no? Here gas is present. There's a fixed plate. There's a heater coil, which will supply the power at a constant rate, supplies heat energy. A heater supplies, so there's a heater coil. That will supply the heat at a constant rate H. The current through the battery at time T. So he's asking something to get expression for this current. Now first we'll study the diagram. What are the things here? So usually see all such. So as I add this heater supplies heat. So first what will happen? The gas will absorb it. The gas will absorb it. Then the gas will expand. So then slowly what happen? This will be like a from rest to rest, it will be moving. It's not something like it will accelerate. One of the plates is fixed, the other can slide in a cylindrical chamber gradually. So there's particular sentence, what happened, the word he has to add. Otherwise what happened, I can't end up, so I can assume any other thermodynamic process. Gradually means, so in infinitesimally means it will move from rest to rest, rest to rest, rest to rest, it will be. Then what will be the pressure of the gas? Will be constant. If this accelerates, definitely the pressure here will be greater than P naught. It can also happen that pressure is greater than P naught and the pressure difference constant, then it will be isobaric process. That's what's going to happen here. So there are three cases are there. If it moves from rest to rest, so what we can call like the pressure inside the gas will remain P naught only. Next situation, the pressure will be greater than P naught, net force will be non-zero, and it will have constant acceleration. That case also will be isobaric. Another situation, the pressure will be continuously varying. It will going to describe variable accelerated motion. Then it cannot be isobaric process. Pressure will be varying. Okay, fine. So I'm going to assume that it will move from rest to rest gradually. So this word gradually is what? Let me add. Sir, you are adding to get answer. Yes. See, like I assume that some general thermodynamic process, solved it, integrated, nowhere related. Then I thought like maybe P greater than P naught, assumed it. Then that one. When I assumed it pressure of the gas to be P naught, I got the answer. So therefore I'm making some changes. Don't blame me. Something. Otherwise, it will become a very lengthy question. Three situations we have to assume. For the options to be correct, I'm assuming this condition. Okay, fine. So in a advanced exam, what will happen? If it doesn't mention gradually, then I don't know, like they have to go for add mark. That's all. There's no way. Okay, let's get into this one here. So what is the pressure of gas? Will remain P naught. It's a teaching job. Somebody said very easy. Such questions will come now where the information not sufficient. Definitely, I want to share these ideas with the student. No, so I should correct myself first. No, that one. Such questions no will kill our time 1-2 hours. First, I assume something will accelerate. No, 1 hour. Then again 1 hour. So almost 2-3 hours we'll be fighting with this question. So it's not that something we are robot where question come, answer will come. We should have a first clarity to share in front of you know, where to cross check in all angles. Conceptually, I should not describe the wrong concepts here. It's not that easier. It's don't think that I'm very happy here. I'll also will be struggling like you. How you struggle to get a rank, no? I'll be struggling to gather the best numericals and to share them without any error. The struggle will be a continuous process. Let's get into thing now. Okay, at any distance, so what is the capacitor? So shall we say like this is a capacitor? So this is a fixed plate. So I'll use word plate so that capacitor concept will come into picture. This is a movable plate, gradually moving plate. I think if you can think this much, you can crack this question. So what is the capacitance at any time? So F naught AX. So therefore, what is the charge in this? Let it be Q. Q charge be deposited here minus Q. Then the electric field will be E. So therefore, what is the Q should be equal to C into this electric field. So sorry, the instead of this electric field, we'll take this as potential difference, no? Oh, what all I did. I'll bring corrections, sir. Yes, sir. Alright, yeah. No, so this will be, if you want to write E naught electric field, so let me take this much only. Okay, minus Q. What is the charge? Charge should be equal to C into E. E is not electric field, applied EMF. I think many places I have to change. Let me keep this one. So this should be equal to charge equal to C into F naught A X into E. Expression for current. So what is the current rate of flow of charge should be? So therefore this I is equal to dq by dt minus of F naught A X square dx by dt into E. Let's keep this. This is the expression for current. Now let's come to the pressure of gas to be remain same. So what is the using ideal gas equation? P naught AX should be equal to nRT. So therefore X equal to nRT by P naught. I'll differentiate this dx by dt equal to nr P naught dt by capital T. Why I'm thinking, because I have a power here, no? Power, what you can write it as rate of flow, rate of energy. So so I'm supplying this isobaric process. Go for isobaric process. You are going to supply heat. A part of it is used to rise the temperature. Remaining is used to do work. In fact, here, sir, what is the work done by gas? Do we know work done by the gas? That's also a big question. So as it is isobaric process, so what is Q equal to NCP dt? NCP dt. Then I'm supplying at a constant rate. So what is the power absorbed by the gas at a constant rate? That is equal to H. So that H equal to NCP rate of change of temperature, shall I write? And what is rate of change of temperature? I have this equation, but I don't know dx by dt is what we have. Shall I interlink things? So as gas undergoes isobaric process, so therefore d dq not charge, it is this should be equal to ncp dt. So what is this I'll integrate, differentiate this one. Dq by dt is what? H is equal to n cp dt by dt, shall we write this as P naught A nr dx by dt? N will get cancelled. Cp, what type of gas? Monatomic, no? Phi r, phi by 2. Phi by 2, P naught A dx by dt. I into what shall I write? Okay, I into x square epsilon naught A. The current through the battery at time t. How to bring that time into? At time t is equal to spelling. Is I. Okay, I'll do one thing. This is dx by dt. I'll bring later on.
Sir,
Let me finish off. In the end, you can assess. So dx by dt. So this will be Cp will be phi P naught A by 2 dx by dt into h. So dx is equal to 2h by 5 P naught A into dt. The time, he has asked the time. So this will be initial was x naught, no? Let me integrate. I'll wind up. I'll wind up. Then you can ask. Okay, this is the at t equals 0, it was x naught at any instant. So now this will be x minus x naught 2h by 5 P naught A t. So let's come for this one. So what is telling? X is equal to phi A P naught x naught. T is what? Value of t will substitute here. I have, so I'll proceed like this. 2h phi P naught A. What is the t? T will be phi A P naught x naught by 2h. So 2x naught will come. The time at which he has given, no, that is equal to 2x naught. Okay, let's get into expression for current. So therefore, dq by dt is what? Current, no? Okay, this is able to understand that there's a data given. I'll shade it from where I substituted. There's a given thing. That's why I substituted here. The time at which is asking. The current through the battery at time t. The charge on capacitor at this instant is q. Pick up the correct option. So we have to get expression for I and q. So tell me, like, what shall I do here now?
substituting.
So substituting it. So I'll take help of this equation. What is the value of x? Will be 2x naught. Dx by dt. What shall I write? This much here. X as, I'll do one thing. I'll write equation 1. I think they are going to help. Equation 2. So expression for I should be equal to substituting 2 in 1 and x equal to 2x naught. This is equation 3. Solving 1, 2, 3 will get expression for current. And afterwards, what is the expression for charge? So substituting x equal to 2x naught will get the charge. Okay, solve 1, 2, and 3. And you'll get expression for current. This will be the option, sir. Somebody were asking question.
Sir,
Uh,
you said you're taking at constant pressure now, sir.
yeah.
How can it be constant pressure, sir?
Why? What
Some
is the problem?
electrostatic pressure will also be now, sir, when charge is getting added up. You have to consider that also.
So it moves gradually, no?
But also some electrostatic pressure will be now, sir.
You mean to say that the electrostatic force will be acting?
Yes, sir.
If electrostatic force acts,
What a quadratic equation for x
oh,
terms of
I
x
don't.
if I did like that.
Then what happened? We'll get a quadratic. That again here neglect force of interaction between the plates.
Okay, sir.
I'll add that also. I think I forgot that also. Neglect force of interaction. I think I'll add here.